Okay, so section 3.2 is exponential modeling. It's kind of, how do we use some of this exponential stuff in real life? And I told you, this is kind of relating to our real world problem right now. They are always measuring their exponential growth on this virus, the rate of growth, that kind of thing. Anyways, so we're going to do some exponential modeling using our exponential function from previous. So let me just remind you kind of what that looked like. Remember, it looked like this. That's kind of the generic, just kind of the math way to write it. But they do have one that they use, and it looks a lot like, it looks familiar or similar to all the things that they use. The one in the book that we're going to use, they talk about a population. A population model. Sorry. There's also one, and I'm sure you've seen this maybe in a different class, but they do it for interest rates and science stuff like the growth of rate and decay in science stuff. But anyways, the one that, like I said, the one they use in the book is a population model. So it looks like this. Okay, so it looks similar to what we have up here, just a little bit different. So this would be our A, and this would be our B, and of course then we have our exponent, which would be time here. So it's very similar, set up just a little bit different to include what we call a rate of growth or decay. So let me go over these. P naught is just like our A, which is our initial, remember it was our initial value. Here it's our initial population, but no matter how you use this equation, we use a little bit different. In a few examples, it's always your just initial value. Remember that from, using it before. Then your R is your rate. It's usually your rate of growth, your rate of decay. And you always, they give you a rate in percentage, but you always want to write in the equation as a decimal. Okay, and then T, that's of course time in years, usually. It just depends on the problem. We'll just say for now T is time. Okay, so if you want to write anything down for your homework, this equation right here would definitely be what you're going to use for your homework problems. So write this down. Okay, so let's do a couple of examples. This first example will be, I'm going to try to do some problems similar to your homeworks to kind of line up. But this example says, is this a growth, is this a decay, and then find the rate of growth or decay. Okay, so remember this was like our A in the previous sections, and this is our B. So if our B is greater than 1, we call it a growth. So we know it's a growth because it's greater than 1. And then we want to find out what the rate of growth is. So remember in this parentheses right here, we have 1 plus r, and that equals this number right here. So 1 plus r equals 0.0064. Just making sure I wrote that down right. Okay, and if you do the math, you get r equals 0.0064. And then remember, we want to put rate in percentage when you write out rate. They'll want to know the percent of growth or decay. So in this case, we have a 0.64% growth rate. Okay, so that's how you do that. And then B, Detroit. If you know anything about Detroit, you know what this is probably going to be anyways, because they closed a bunch of the factories in Detroit. So B is less than 1, so that means it is a decay. And again, if we do the math and solve for our R, Okay, we would get a negative number because because it's a decay. Decay means you're going down, if you know anything about just the definition of decay. So then we would multiply by 100, and so 1.42% decay rate. So notice we didn't write negative percent, because when you say the word decay, you already know that it's going to be going down, not up. Growth would be going up, decay would be going down. So you would have a 1.42% decay rate. Okay. All right, next example. Next example is we're going to write the exponential function. Okay, let's remember from the beginning kind of what it looks like. Okay, so determine the exponential function with the initial value equaling 12, increasing at a rate of 8% per year. So initial value, this must not be a population obviously, but something that's we're measuring, but the initial value is going to be 12, and then our rate is 8%, which when we write that in decimal form, we want to divide by 100. So 8 divided by 100, 0.08. So we're going to write that in decimal form. And then our last step is we are just going to go ahead and do the math in the parentheses. So 1.08 centi. Pretty easy. Okay, so then some of the other problems, this is called radioactive decay, and they actually measure time, I believe in weeks. I'm sorry, I'm not really sure. I believe in weeks. And so the equation, while the equation is the same, they just say it a little bit differently. Okay, so I actually already wrote on this, my little notes for myself, but determine an exponential function with initial mass, so we know the initial, and it's doubling every 4 days. Okay, so that means t would be divided by 4 here, and doubling means the number 2. Okay, and so we would write, this talks about mass, so we'll have an m, and this is kind of what this formula looks like. Initially, we already know the initial mass is 1.3. And 2 is from our doubling. Okay, and then t over 4, because every 4 days. And that would be the answer here. Okay, I believe that's it. So get started on your homework. This should be a pretty easy one. Just use the equation, use your notes, and I will be happy to answer questions. Love you guys. Thanks for being patient with me. Hope you're doing well. Stay on top of your homework, and I miss you.